So for test 3, we're going to start looking at material from chapter 7, and the first of it is radical expressions, radical functions, and rational exponents. So a little bit of terminology. We're going to see this symbol a lot. This is called a radical. The principal square root of a non-negative number a is its non-negative square root, written as root a. The expression under the radical is called the radicand. And in the expression that looks like this, the x is the index. And when we are talking about a square root, the index is implied and we don't actually write it. So for square root, we just get the symbol, where for cube root or some higher, we'll actually have an index showing. But when the index is a 2 and it means square root, then it's implied, kind of like when we have x to the first, we don't write to the first power. Alright, now this first material, the problem with it is it's a very simple idea, but of course we're going to complicate it. So it says find each square root, assume all variables represent non-negative real numbers. So for the first question, this is something that you probably all know, right? We know that the square root of 4 equals 2. The problem is we really need to understand why that's true and how to write mathematically that it's true, because the stuff that we're going to deal with coming up is going to require it. So I'm going to write here the square root of 4 is 2 because 2 times 2 is 4, or you can think of it as 2 squared is 4 because 2 squared just means 2 times 2, right? So what we need to know is that squaring and square roots are inverses of each other, and that means that they undo each other. So the reason that the square root of 4 is 2 is because if I wrote the square root of 4 as the square root of 2 squared, remember we don't write this number, but that index is a 2, right? So that square root and this square undoes each other, and that leaves me with 2. Alright, so number 2, for this one, it's going to be very important to pay attention to the negatives and where they are and what they mean in these problems. For this one, you see that that negative sign is out front. It is not under the radical. So this is the same as having negative 1 times the square root of 4. So in problem 1, we already went through what the square root of 4 is and why, right? So this is just negative 1 times we know the square root of 4 is 2. So the answer to this one is -2. For the third one, the difference is now the negative sign is up under the radical. So this one is actually not real. And the reason is because if a number has a square root, that means that there exists a number that if I multiply it times itself will give me the number that's under the radical. Well, we know that the root of 4 is 2. So if you're not convinced, if I multiply 2 times 2, I get 4, not -4, right? And if I multiply -2 times -2, I also get 4, not -4. So if you think to yourself next, well, what if I multiplied 2 times -2? Well, that won't meet the definition of a square root. The square root is a number times itself. So it's something times an exact copy of itself. So if I have a negative under what we're going to talk about a little later, an even root, then the answer is going to be not real. Alright, for the next one, the square root of 0.16 is going to be 0.4. And again, that is because 0.4 times 0.4 equals 0.16. Of course, or you can look at it as 0.4 squared equals 0.16. So that would mean if I take the square root of 0.4 squared, the 2's would undo each other and leave me with that 0.4. Alright, so the next thing is approximating roots, and this is pure calculator usage, okay? So if we're dealing with square roots, if I have a number under the radical that is not a perfect square, then we may approximate it. So make sure whatever calculator you're using, you can enter the square root of 30, and I wrote that down as 5.4772 because you see I said in the instructions to round to 3 decimal places. So here's my decimal. So this is 1, 2, 3 decimal places. So we need the fourth one to tell me whether or not we're going to round up, right? So the 2 will not tell the 7 to round up. So my approximation is going to be 5.477. And that's all that one is using the calculator. Alright, for the next one, this is where I was talking about the stuff from those first problems that we were going to complicate them because we were going to need it, and we're going to need it here, and we're going to need it in many of the sections to come in this chapter. So if I want to take the square root of x to the 16th, then I need a way to figure out how I can simplify that. And if you remember back, we had an exponent rule that we learned on the first test that said a raised to the m power and the whole thing raised to the n is equivalent to a to the m times n, which we called power to power multiplies, right? So what we want to do, that square root, my index of 2 is not showing if you want to think about it being there. What I want to end up with is the square root of something to the second power so that I can reduce or cancel those 2's, right? So we can use that rule. Remember, if I put x to an exponent in here, the exponents are going to multiply. So if I need 16, I would need x to the 8, because x to the 8 times 2 will give me 16. And then once it's in this form, those 2's can cancel, so I'm left with x to the 8th. Alright, for this next one, it's the same idea. It's a square root again, so we want x to a power to the second power so we can cancel the 2's. So I want to know 2 times what will give me 8, and that's going to be 4. So then if you want to write that in small and light just so you can see it, those 2's can cancel, and I'm going to be left with x to the 4th. Alright, and of course for the last problem, we saved the best for last, right? So for this one, we have a number and we have a variable expression. We need both of them to be to a power of 2 so that we can cancel the 2's. So 4 is a perfect square. I can write that as 2 squared. And x to the 10th, I'm going to do like we did problem 1 and 2. I'm going to say x to the what to the squared. So I want to know what times 2 gives me 10, and that is 5. So then the 2's can cancel, and I would be left with 2x to the 5th. Alright, for finding cube roots, the cube root of a real number a is written as, now my index is going to be a 3, so it's cube root of a. And the cube root of a is equal to b when b to the 3rd is equal to a. That just says the same thing we were talking about with the square roots, that a square root means it was something times itself or something squared. So a cube root is something times itself 3 times or something cubed. Alright, so if we look at the first one, again, this is going to be the same thing as I talked about in that first set. These are simple problems that we can go straight to the answer, but I need you to be thinking through and showing this process because we're going to need it. We know that the cube root of 8 is 2. The reason for that is because 2 times 2 times 2 is equal to 8. Of course, we could also say that that's 2 cubed. Something times itself 3 times is that thing cubed. So that would give me the cube root of 2 to the 3rd, and just like we did before, since those are the same, we can cancel them, and that leaves me with a 2. Now for the next one, your first thing might be to say that this one is not real, but we're going to learn and do a lot more with this. What we're going to find, it makes a difference whether the root that we're dealing with is odd or even. 3 is an odd root, so this one does actually exist. If you want to prove that to yourself too, you can put in the calculator cube root of -8, and it'll tell you it's -2. The reason that this one is okay is because -2 times -2 times -2 is -8. So when we're dealing with an even power, nothing times itself can give me a negative. But if the power is odd, if I multiply an odd number of negative things, I get a negative. So we could also say that this is, and again, this is one of those important places, it's -2 in a parenthesis to the third power is equal to -8. So that's what allows me to say that the cube root of -8 can be written as the cube root of -2 cubed. Then we can cancel those 3's, and that's where we get the -2. For the next one, there's a couple of different ways you can look at this. If you want to split it into cube root of 1 over cube root of 64, you can do that, and we're going to do some of that later. But right now, we're just trying to get the hang of writing these things as the powers so we can cancel. So I'm going to say this is 1/4, and that's because 1/4 times 1/4 times 1/4 is 1 over 64, which can also be written as 1/4 cubed. So that's what allows me to say that the cube root of 1 over 64 can be written as the cube root of 1/4 cubed. The 3's can cancel, and I'm left with 1/4. Alright, for the last one, this one, we're going to go back to using that a to the m to the n is a to the m times n. So I don't want x to the 9th under there. I want x to some power to the 3rd because the index is 3. So I want to know what times 3 right here will give me 9, and that is a 3. Sorry, that's a lot of 3's. So this one and this one can cancel, and that leaves me with x to the 3rd.